All right. So, hello to everyone. Last week of class. Um, but before we do any content, I'll just sort of try to explain to you how to complete this final uh, set of labs. Um, so I have the browser up, and let me just go to talk about the deadline. So most weeks we do Sundays, right? But this week the semester ends officially on Friday, May 29th. So that's the last day to turn in this final lab is this Friday, May 29th. At which point all of our summers start, so they'll all still have some grading to do. So please mark that down somewhere so you don't forget. Friday, May 29th is the last day to turn in uh, this lab. And also pay attention to the amount of points it is. So it's 300 points, which if you're if you're still here after this much time, you probably don't care about the 300 points anymore. But for a tiny number of you, that 300 points might matter, so you don't want to not do this lab. It's sort of a two-part lab, so you could get 150 points for each of the two parts. So my plan, so I'm going to go back to the schedule. My plan this week is today we're going to do um, two parts, both parts, and then I will be here as usual tomorrow for a question and answer to help people clean that up. And then on Thursday I'll be back and we'll do a different two parts. So officially you can be done with the class if you do the two parts that we do together today. But if you want to see more or hear more, then I'm going to do more on Thursday to try to give you your money's worth. So I will end up doing 4 mini labs in C++ as a way of giving you guys some exposure to the C++ language. The reason why we do this is that for some of you, if you go on to Programming Algorithms 2, that class is in C++. And I want you to feel that it's not anything to be worried about. The Go language and the C++ language are, on the whole, very, very similar to each other. The Go language has tried to make programming less intimidating than C++ makes it, but you'll see a lot of the same kinds of things. My first programming class, by the way, was in the Java language, and my second one was in C++, so I've been through this myself. And I didn't find it to be that big a deal after a bit. I mean, I had to look at references and stuff, but that was before you could find everything on the internet. So I think you'll find that once you realize that it's not that big a deal, and you just practice and you get some muscle memory for C++, you'll be just fine. Okay, so the final lab. The first 3 things are just setup. So this has been out there, and I've mentioned it I think a few weeks ago at this point. And we did a few of us stayed one day and we went through the install process, which is not super straightforward in Windows. So just heads up if you intend to install C++ on your Windows machine. It's not super straightforward. You're going to need the internet's help. If you're on a Mac, you can install Xcode, and that comes with all the C++ stuff in it. I also recommend that you install the command line tools for Xcode on the Mac. Or you can avoid all of those hassles and just work online, which is what I'm going to do today. So if you haven't done it, right now is the time to go to repl.it and get yourself an account. If you haven't done that before now, you probably are going to want to come back and view the video because I'm not going to make everyone sit around and wait while we create accounts. So this is the easiest way to do the final lab. Then what we have here is a link to programming challenges from the fall of 2017 when I taught your class, Programming Algorithms 1 in the C++ language. It works well for us, though, because I kind of started them at the more complicated end of things, and then we sort of worked from there, whereas in your class I started at the basic building blocks and then got to the more complicated things at the end. So you can sort of step right into these challenges and hopefully make some sense of them, even though they're going to look a little different because they're in C++. Okay, so I will be working in Replit. Um, maybe I should bring up a text editor for this part. I think I might do that. No, I'll just type it in my REPL. So what you're going to want to do is this week I'm going to do 4 C++ labs. Your job to get the points is to submit 2 of those labs. If you want to submit more, you can, but submit 2 is the requirement. And what you're going to do is you're going to create a new REPL for every lab. So at the end, you will have 4 new REPLs plus whatever other REPLs you create on top of that. REPL, by the way, what that stands for is read, evaluate, print loop. Read, evaluate, print loop. What that means is it's kind of a fast feedback kind of programming style. It's kind of what that means. But anyway, if you Google REPL, R-E-P-L, it stands for read, evaluate, print loop, which is it's a way of getting feedback as a programmer. For us, this just means little virtual environments in the web browser. So this is free, Replit. You can create, as far as I know, as many REPLs as you want. You're going to create 1 per assignment. Now for us, we've already done Programming Challenge 1, probably a couple weeks ago now. So I'm not going to have the regular attendees watch us work through that one again. So I'm not going to do that one again, but there are videos on Twitch and YouTube. If you read the descriptions, you'll see where we talk about working through one of those challenges. I'm going to start on Programming Challenge 2. So remember, the final assignment, if you click the complete 2 or more challenges here, takes you to an earlier semester of mine. Programming Algorithms 1 in C++. And I'm going to do Programming Challenge 2. So I'm going to click on that. It looks scary because there's a lot of stuff going on, but it's not scary. So if at any point you need me to hit pause or repeat something I said, please let me know. I'll try to pace myself. But I also want to make sure that we've gotten through 2 labs. So this will be the first of the 2 labs. So I'm going to create a new REPL in C++. Let me escape. So I clicked on the new, can you see everything? Yeah, you can. Okay, so I clicked on the new REPL button. I'm going to choose C++, and then I'm going to call this, for me, I'm going to call it Bootcamp 1. And then when we get done with one of these exercises, I'll show you how to submit it to me. And you have 3 ways to do it. I'm not going to touch anything else. If I switch this public to private, they're going to want me to pay money, so I'm not going to do that. I'm not going to touch the GitHub tab. I'm just going to create a new C++ REPL called Bootcamp 1. I will end up with 4 of these this week, and then create REPL. And then it should, now I've changed my layout. I'll show you the way to do that. You should get a setup like this. You can click run just to confirm that everything works, and you can see down here at the bottom where it printed out hello world. The way it does outputs in C++ is weird looking at first, although all of this part you recognize. It's hello world exclamation point and a new line. That's all it did. And then this weird stuff at the front, which is very C++. Okay, so I'm going to wait, and maybe in chat, can you just give me a go or some kind of sign that you're good to continue, and once I get 2 or 3 of you who I'll kind of have a sense that my pacing's okay. You need 2 tabs open in your browser, by the way, one for the challenge and then one for the REPL. Okay, great. So before we do any actual work, sweet. Okay, before we do any actual work, let me just show you around the interface a little bit. So you have the run button, which is what you'll click when you're ready to try out your program. Over here on the left, there's a menu, so it'll take you to home, a list of your REPLs that you've made. We don't need any of that stuff. I don't know if you see teachers or not. Anyway, call these a hamburger menu. Click that to close it. There's if you click this files thing, see it makes your little files display open and close, so that's all that does. We're not going to do version control, but if you were to click on it, it would ask you about doing some Git stuff, which I'm not going to do, so I'm going to close that. And then this last one is settings. And in settings, I'm using the stacked layout. You can use the side-by-side layout, which moves the terminal part to the side. But I like the stacked one when I'm online. You can change the theme from light to dark. I think that looks good, but I don't know that I like it for broadcasting so much. But anyway, if you decide you like the light better, you could let me know. You can change the font size. You can change the indent type, but leave that as spaces. The indent size 2 is standard. And then there's a few other things about code wrapping and whether or not the code helpers pop up. Anyway, that's what the settings are. So you can always just click on stuff and then click it to make it go away. I like the main change I make is to use the stacked layout. So, and by stacked it means that the code editing is on top of the terminal at the bottom. I'm going to reopen the files. Okay, so just to give us a little bit of a warm-up, I'm going to show you how outputs work, and then we'll do some scarier stuff. Okay, so should we leave it this way? Probably for now. No, let's not leave it. So this, well, let's do. So let's just practice outputs a little bit. So that probably makes sense. There's another output. I'm going to do some in between. So to create variables in C++, the data type comes first. So in Go, I would type this if I wanted an integer variable. I would type this actually, right, in Go. In C++, you put the data type first, and then the name of the variable. And then you'll notice in C++ there's semicolons all over the place, which is one of the things that Go cleaned up, is to take semicolons out because they don't really help in most places. The other thing that you'll see C++ programmers do is give their variables initial values. So this is just declaring the variable x, which is an integer and has a start value of 0. Now in the Go language, variables get 0 values automatically, but in C++ they don't. Which is why you'll see C++ programmers create variables, give them values. I'll make an x and a y. In fact, let's give them more interesting values, just like 5 and 2 or something. Alright, so there's my two variables. Alright, so just a quick primer on doing outputs. So every time you need to switch from one kind of output to a different kind of output, you have to repeat this operator. We call it the insertion operator, which when I was learning C++ never really made sense to me why we called it the insertion operator, but it's called the insertion operator. So this standard : cout, it references what we call the standard output device, which on computers is the terminal. So that std : cout is referring to the terminal screen. So this will be output or displayed to the terminal screen. So that's how I put x space equals space to the terminal screen. Now when you need to switch from one kind of output to another, you repeat that operator. So I want to switch because I want to use the actual variable x here. So I switch from a literal string to getting the value of a variable, and then I'm going to switch back to a new line character. So these can look pretty rough at first until you get used to it. I'll do another one. Y space equals space, switching to the variable value, switching. And here I'm showing you the other way to do a new line in C++, which is called end line. So this is ENDL, which has the same effect as the new line character, which is just line break. So this is a line break at the end of the line. This is a line break at the end of a line. They have the same effect. I'm going to click run just to see those outputs. And then you can see at the bottom, there's my hello world, line break, x equals 5, line break, y equals 2, line break, goodbye, line break. So while we're here, notice how we have all these std : everywhere is this mess std : it's unpleasant to type and unpleasant to look at, so we can go up here to the top and we can give ourselves basically a global access to that std. So it's called a using directive, and it goes below the include, but I say using namespace std, and then I don't need std : anymore, which is a lot easier to look at, I would argue. So the outputs do look different, and they do take practice, but they're not that big a deal. I mean, I like the fumped printf style better, but this is sort of the C++ way. Now I did this in part because I wanted to show you that like all of the arithmetic, so x plus y equals, all the arithmetic is the same as in Go. So add, subtract, multiply, divide, mod, those are all the same. Now this is just going to say x plus y space equals space. If you want literally the value of x in the output, then you would have to say the value of x output, and then switch to have, I'm not typing what I want, switch to get the space plus space, then switch to get the y, then switch to get the space equals space, then switch to get the, actually let's do minus, or let's do mod, what the heck for, x mod y, so there's the actual math being performed and displayed, and then end line. So I did that second one just to show you that it does take a little bit more work to construct one of these fancier outputs. Hold on, I gotta scratch my nose. Okay, so that's just a little bit of a warm-up, and just to point out to you that one of the places where it's going to feel funny is these outputs are going to look weird. So I will try to sort of talk through them carefully whenever I do them. But notice every time I switch from like a variable to a string, to a variable, to a string, to a variable, or a computed value, to a line break, I use the insertion operator. So you sort of just plug these things in. Okay, so now I'm going to make this whole thing go away, because we want to work on the lab. So let's see what the lab wants us to do. So after creating your project, download 2 files to your project folder. Yeah, let's do that. So I'll try to go slow on this part, but let's do that. So here's what I'm going to do. I'm going to click on this link right here just to open the file in my browser. And you should get a bunch of stuff. So we need to be very careful here, so I'm just sort of slowing down to say this. Notice how this is spelled. Capital C-I-N, capital R-E-A-D-E-R dot H. This is something that I wrote many years ago now. I call it CN Reader. So what it is some code to help keyboard inputting. Um, in Go, that's fairly easy, but in C++ it's not. So I wrote some code to make it easier for us many years ago. So just pay attention to the spelling, cnreader.h with a capital C and a capital R. Those things are going to matter. But anyway, I'm going to do Control A, Control key and the A key to select all, and then Control C to copy. Now if you have other ways, but basically you want to copy all this text, right? So Control C to copy. And then I'm going to go to my REPLit, and I'm going to click this Add File. So I'm in my REPL. I'm going to add a file. I'm going to call it cnreader.h, and notice that I spelled it exactly the same. Capital C-I-N, capital R-E-A-D-E-R dot H. Spelled it exactly the same. So just be careful that that's exactly the same. If it's not, you'll have to fix something. It's not the end of the world, but you will have to fix something later if you get it wrong now. Hit enter when you're happy with the file name, and what should happen is it then opens it in its own tab up here, cnreader.h, and it has no contents, but I'm going to do Control V to copy, Control V, and there's all that stuff that I just grabbed off of the assignment. So it has a license statement at the top, has this pragma thing, it has some includes. Includes in C++ are like imports in the Go language. Here's that using std trick, which just means that when I wrote this I didn't want to put std : everywhere. And then it has this class cnreader thing in it. So hopefully that's good, but I'll also kind of let chat tell me when you're good to go for the next step after you have cnreader.h. So you should end up with main.cpp and cnreader.h at this stage. Yes. So if you're working on your local machine, just make a new file and don't save it as CPP, save it as .h. But just save it in the same folder. So if you're working on Atom, make this file in Atom with cnreader.h as the name and save it in the same folder. So the name is very, very important. It has to be cnreader.h or something else. We'll have to make some fixes somewhere else later. So if you look in the folder where you're doing your work for this bootcamp lab, you should right now have two files, a main.cpp file and a cnreader.h file, two separate files, just like in REPL here. Okay, hopefully we're good to go another step. I want to, because you know, when you're doing on the fly live, if you get behind a little bit, it's hard to catch up. So just ping chat if you get behind, and we'll stop and make sure that you got it. I'm going to go back to the lab though. Okay, great. So Tyler's good to go. So I'm gonna go back to the lab and repeat the same process for cnreader.cpp. So if I click that link on the lab, I get a different file. It has cnreader stuff in it, but it's different stuff. And same thing here. Take note of the name. cnreader.cpp, capital C-I-N, capital R-E-A-D-E-R .cpp. So need to remember that. It's very important to get that exactly right as well. So Control A to select all, Control C to copy. Then I go back to my REPL. I need another new file. This one's called cnreader.cpp. And again, be careful of the spelling. If you spell it wrong, at some point you may have a problem that you'll have to fix. It can always be fixed, but it's less frustrating if it just sort of goes right. When you have the name right, hit enter. And then you get this new CNReader file that's empty. Control V copies all that stuff that I just got. It's a whole bunch of code. I don't really have to worry about what the code is or does. I'm just going to use it in my lab. Why is it so long? For some reason that it shouldn't be that long, I think. I think for some reason it was accidentally like pasting stuff over. So it's 406 lines. Alright, so when you're done, if everything's right, you have main.cpp, which right now has, I just have nothing in it. You have cnreader.cpp, which has 406 lines of a whole bunch of code. And you have cnreader.h, which has 244 lines of a bunch of code. cnreader.h is the one that has the license statement at the top. cnreader.cpp at the top has an include statement. So that whole rigmarole that we just did with these two CNReader files, that was so that we could do some keyboard inputs in our programs and it not be so miserable to code. So this is designed to make it a little bit easier to handle keyboard inputs in our programs. Go's built-in way of doing keyboard inputs works good enough in many cases. Okay, so hopefully we're all still doing okay. We haven't worked on any program. Once you have the two CNReader files here, you don't touch them. They just need to be there with the code that they have in them. Okay, so what does this thing want us to do this lab? Declares one class named student with some stuff. With a bunch of properties and a bunch of functions. Okay, so let's do that. So a class named student. So in C++, well, let me show you what it would look like in the Go language. So what we're about to create would look like this in C++. Okay? So we're going to create something like this, and it's going to have first name, which is a string. You guys don't need to do this part, middle initial last name ID. I'm going to do this part for us, so just so you have it to compare. Initial, which is probably a character. Yep, last name, ID, GPA. Last name, which is a string. GPA, which it would be a float 64 in Go. Oh, an ID and a currently enrolled. I forgot ID, which is an integer, a GPA, and currently enrolled, and reader. Okay, currently enrolled. And reader, which will be a CN reader thingy. Okay, so you don't have to code this part. I'm just showing you this is what it would look like in the Go language. When it says a class in C++, um, in Go, the similar uh, concept is called a struct. Now it's true that there's also structs in C++. They're very, very similar in C++. But what this lab is asking us to do is create something like this, but in C++, with numerous properties uh, like these. So let's do that in C++ now to match what it is asking us to do. So class student. So one thing to notice in C++, that's what the outer part looks like. Notice that semicolon, it has to be there. It has to be there, or you have incorrect code. So make sure you get that semicolon. It's just how that particular thing works in C++. And then properties. So in C++, we're going to create, it's called an access modifier. You don't really have to worry about the term, but in C++, when we create a class and we add properties to it, we almost always create this little section called private inside of it. And then inside of the private section, we're going to put all of the properties. So there's the first name property, and remember the data type comes first in C++. We have a middle initial. Again, the data type comes first. We have a last name. We have an ID. We have a GPA. So this is the first time that it looks dramatically different. A double in C++ is a float 64 for all intents and purposes. In C++, we call that a double, which stands for double precision floating point number. So in Go, they went with the float part of that word, and in C++, they went with the double precision part of that phrase. Bool currently enrolled and CN reader. Okay, so there's that same student struct that will call a class in C++, and then all of the properties go in this section called private, labeled as private. Hopefully that's going okay for everybody. Now eventually I'm going to take the Go code out because it's using up so much screen space. Okay, so hopefully you're all doing okay. I'm almost out of my water, so I'll give you a break here in a second maybe. All right, so there's my class student with all the properties. I need to add a couple of includes up here. So one thing I need to add is include string, which you don't have to do this in the Go language. String is just sort of automatic, but in C++, string isn't automatic. So you have to include it. And then we also need access to that CN reader code. So I actually usually put this way at the very top like this. It is important that this is with quotes and not the greater than less than bracketing. The quotes tell C++ that this is a file in this folder. These other includes are part of the C++ installation. But this is a file that I just created in this folder. I'm just pushing this down so you can see the whole screen. So that's what I got right now. We should be able to click run and nothing happened, I think. Yeah. So I clicked run just to see if anything happened. Nothing happened, and that's a good thing. I didn't want to see errors. So it's amazing how much difference the semicolons makes or not. Like without the semicolons, it's so much easier to read for me. But this just is the way C++ works. Um, so this CNReader reader part, by the way, that is how we're going to access the keyboard reading code that we have in these two files, is with this thing right here. Okay, so I'm going to go back. So I just did the 7 properties. First name, middle initial, last name, and it's telling me the data types here. Oh look, it even said you need an include statement for cnreader.h, and we did that already. Okay. Okay, so let's work on functions. And I'll show you what one of them, maybe 2 of them look like in Go, and then we'll do it in C++. So we're going to make a function called read first name that reads in a first name from the keyboard. Okay, read first name. So in Go, this is what this would look like. Or this is how I would write it. Input, and then I would say s dot first name equals input. So this is what this thing that we're working on would look like in the Go language. We call that a method in Go because it requires a s dot, a student dot read first name, which is kind of the effect we want in C++. So this is, we're about to build this in C++, but you probably recognize this code. So this is a method, meaning it's called on a struct, in this case a student. The name of the function is read first name, and it has no return type. So it prompts for and reads in and then stores an input as the student's first name. That's what we want in C++. Now I need to get rid of this stuff because I'm burning up too much screen real estate on it. Hopefully that's okay. So how do we do that in C++? Well, in Go, the methods are created separately from the struct, but in C++, they're created inside in a public section. So we have the properties in a private section, and we're going to make the methods in a public section, but they're actually inside of the class. This is so a function in C++, the return type goes first, and if it doesn't return anything, you put void. So let me undo a couple of steps. Okay, so in Go, if the function doesn't return anything, you just, after the function name, there's nothing right here. In C++, the type comes first, and we put void. Alright, so let me get rid of that. Go into the class student, make a public section. So this is a function that doesn't return anything, called read first name. One thing you'll notice is there's nothing in front of the function. Because it's inside of student, in C++, it understands that it works with a student because of the fact that it's inside of the student class. But we're going to repeat the same thing. So cout, enter first name. So there's one of those outputs. And in this case, we're just going to go straight from the input into the variable. So it tends to be more common in C++. First name equals, and then we're going to use this reader thing that we created. This reader right here. So it's spelled the same. To read string. Now the reason why it says read string is because I want to get the first name, which is a string. So the main point about this exercise is not to make you a master of C++. It's just so you've seen a slightly larger body of code in C++, so that when should you come around to it in the near future, you'll be comfortable and you'll recognize it. So don't worry too much if you're not like internalizing concepts here. Just sort of take in the code. We'll try to get something that works so that you have that experience. But mostly it's just so you can kind of note what does look familiar and what doesn't. So the functions, they're a little different, but they're not that different. They still have the block around them. Outputs are a little different, but they're not dramatically different if you kind of understand where the outputs are coming from. We do this kind of thing and Go all the time, where we call a method in this case. It returns a value and we store what it returns in a variable. I assume that we're going to repeat that for all of these things. Let's see if that's true. Currently enrolled. Yeah. Okay, so let's just repeat this for all of them. So I'm going to put another method here, void read middle initial. I'm going to say enter middle initial. Okay, I'm still live. I get paranoid about losing my connection. Middle initial, and again, be careful here. When I type first name here or middle initial here, I'm talking about the properties. So I'm spelling them exactly the same because they are references to the properties that are in this same section or block of code. Equals reader dot read. Now a middle initial is a character, so I'm going to do read char. Read char because middle initial is a character. Now in Go we haven't really done individual characters very often. I see more of it in C++. In Go they call those runes, R-U-N-E, which sounds kind of fun. But it's not a data type we've used ever, I think, in our class. Alright, so there's read middle initial. I'm just going to check. I think it has me read all the pieces. Yep, so it's going to look very familiar. And this student section is about to get pretty long because I'm just going to keep adding. So read last name, enter last name, and then last name equals reader dot read. In this case, last name is a string again. And notice, by the way, that string is capitalized because that's really part of a function name, and we're camel casing, just like we do in Go. So there's last name. We need the ID. Reader dot read. In the case of ID, it's an integer, an int, so read int. Now the reason I know that C and reader works this way is because I wrote it. So I know that you do reader.read int for integer, reader.read string to get a string. So I'm very familiar with how it works, is why I can just remember. Because I wrote it even though it was years ago. Okay, I'm gonna keep going. Hopefully we're doing okay. What came after ID GPA? So read GPA, enter GPA. GPA, again, this is a reference to this GPA down here. So make sure they're spelled the same. Equals reader dot read. This one's a double. GPA is a double. So when I read the input from the keyboard for that, I want to get double. And then the last one, read currently enrolled. I'll ask this question differently because it's more like a, but it's a Boolean, so it's a true false kind of question. Currently enrolled. And then currently enrolled property, assign the value of reading a bool. Now this is a lot without clicking that run button, so I'm going to click it. And just make sure that no errors turned up down here. If they did, then I need to go fix. If you see an error, it should reference line numbers in the code, so it should tell you where to go. Just going to push that down so I can get more stuff on the screen. I don't want to let too much time go, but I also want to make sure that you get some kind of a breather because I was just typing away there. Notice how those are all very repetitive. The thing to be careful of is that when you're reading the middle initial, and you say middle initial equals, for example, make sure that what you read matches middle initial. So middle initial is a char, so I read a char. Last name is a string, so I reader.read a string. ID is an integer, so I reader.read an int. GPA is a double, so I reader.read double. And currently enrolled is bool, so I reader.read bool. I changed my question in that case because a bool is a true false, and that's, I know what the library wants is a T or an F or the word true or false there. And then click run just to make sure that you don't get errors. And I'm not, so all good on my end, but I've been around C++ more than most of you, so it's perfectly fine if you find yourself getting an error. The point of reference here, by the way, is this private with the properties, so I just keep adding functions in right in there. One more. Describe. So describe is supposed to print out first name, middle initial, last name, line break. ID, some spaces, the ID value, line break. GPA, some spaces, the GPA, line break. Currently enrolled, some spaces, true, and line break. So let's do that. We may not get it lined up precisely like this has it. We're not going to worry about that. Okay, so we're going to write our new method or function, we call it in C++. Everything, by the way, in C++ we call a function. Go differentiates between sort of standalone functions and methods that are connected to structs. In C++, even if it's connected to a class, it's still called a function. I like what Go does, though, because it explains it better. Describe. Anyway, Alright, so here we go with some outputs. So the first output, which we're doing to the standard out, that's the console, is the first name, followed by a space, followed by the middle initial, followed by a dot, and a space. I can just get those both at once, followed by the last name, followed by a line break. The second line is the ID. Okay, so, oops, ID. I know what I'll do. I'm going to line these things up after the fact. I'll show you what I mean. And then print out the ID and a line break. Um, what's the third? GPA. 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 And a line break. And then finally, currently enrolled. I should have put a currently enrolled and an end line. So that is meant to, and you see what I did here is I just sort of, I spaced these all out. I got like very lucky. I don't know how that worked out. I bet there's just one space in there. That's amazing that I did that just by guessing. Um, anyway, because these quotes are all lined up and I use spaces in here, then in the outputs they're all going to line up real pretty anyway. So that's going to look pretty good. Hit pause. I may only have time to do one each day at this pace, which is okay. So anyway, this does kind of throw you in the deep end a little bit, but this is the same sort of skill level that we've been operating on at the end of the semester in the Go language. So this is just sort of the same kinds of stuff that you, at the same level as you've been working um, in Go at this stage. It's just that semester in the fall of 2017, I kind of threw them in the deep end to start and went about it that way. I'm going to click run. Nothing's going to happen yet, but that's what I want. I just want to check for errors. So no errors, so I'm happy with that. Okay, hopefully I haven't gone too fast because we're up to the end of this one, which is to assemble the pieces. So we have, hopefully you can see that okay. We have, here's the bottom of it. This is all student class. It has properties. It has, in the private section, it has functions, which we would call methods in the public section. And then the last thing is to see all of this work by plugging some stuff into main, just like we would in the Go language. Creates one student object named student1. Alright, so student. In Go, by the way, we would do this. Right, to create this thing we're about to create, but in C++ it turns it around. So what it is comes first, followed by what we call it. So there's student1. And then we are going to go down through all of the read first name. So we're going to invoke all of those methods, or what we would still call functions in C++. So on student1, read the first name. On student1, read the middle initial. So remember, these are my functions that I just wrote, parentheses and all. Student1 dot read last name. Student1 dot read ID. Student1 dot read GPA. GPA, student1 dot read currently enrolled. Should be 7 of them. 1, 2, 3, 4, 5, 6. What's missing? Where's the properties? IDGA current. Oh, CN reader, that doesn't count. We don't read that. Okay, so those are all the properties that are information about a student, and then the last thing we do is describe them, which causes the final output to happen. So all of that stuff on student 1. And I could create a second student if I wanted to and go through the whole process with a second student or with a third student or with more students if I wanted to. So that's how you create what we call a class in C++. We call it a struct in the Go language. In C++, we call it a class with a bunch of functions in it. In the Go language, we would call it a struct with a lot of methods. Anyway, I need to run this thing and let's see what happens. It should be, I got an error. Oh, not student.describe, student1.describe. I'll say true. So there, John B. Trollinger, ID, GPA, currently enrolled. So you'll notice that in currently enrolled for true it put a 1, for false it would put 0. Go prints out the true or false, nicer looking. I can show us how to do that. I'm going to go get some water and I'll let you guys hopefully catch up a little bit, and then I can see if we can address any issues that you're having. So let's see how much I can put on the screen here for you to look at. Hopefully that's enough. Anyway, I'm going to go get some water. I'll be right back. Okay, so let's see. Undefined reference to, yeah, you're missing something. So you need to check your file names. So if you do not have cnreader.cpp with all this stuff in it, and you do not have cnreader.h with all this stuff in it in the same folder. Oh, you're trying to compile, aren't you, Nate? So sorry, you're not in the REPL, you're on your own. So you actually have to add cnreader.cpp to your compile string. That's the issue. Hopefully everyone's doing okay. Is everyone doing okay? Before I sort of talk about how you can send this part to me. Okay, perfect. Baby doll's good to go. All right, good. So that worked. Right. So I'm going to add, let me bring up the text editor so I can put some instructions on the screen. Okay, so what you should do is, let me put my Atom editor back up. Is it going to show? I need it to be on top. Okay, so um, there are three ways you can submit this. One is to copy and paste the code from main.cpp into an email and send to me to. Now I got to switch the view. So what I recommend you do is submit this now and have part one done. The first of your two submissions. There are three ways you can submit it to me. One is you can just copy and paste the code out of here into an email. A second way you can do it, I think, is there a way to download this or not a way to download it? Maybe there's only two ways you can do it because it doesn't look like I can right click on that and do anything. That doesn't do anything. What does this do? Download. Well, I mean, I guess you could download it as a zip. So yeah, you could do that. If you go to these three dots right here, there's download as a zip. So you could do that. It's not my favorite way to do it, but you could do it that way. Is send me the zip. Or the third way to do it is to go to this share here and do a copy REPL link and send me the copy REPL link. I think, right? Probably. Does that show anything? What does this do? No. Copy REPL link and send me the link. Let's see what that looks like before we say for certain that's what we want to do, but I'm pretty sure it is. Or number three, share copy REPL link and email me the link to the REPL. Let's see what mine look like. Yeah, there you go. That does in fact work. So that's the other option for, you have three ways of sending that to me. I'd probably just go for the copy and paste the code into an email, but if you want, you can use the dot 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 menu and download the project as a zip and send me the zip. Or the third option is to click on the share button, and then at the bottom of that there's a copy REPL link button, and you can email me the link to the REPL, and then I can just go look at it in a browser. Any of those three ways is acceptable. Okay, so I hope, um, same difference, yeah, Nate. So just um, you only need send me main.cpp. So just send me the main.cpp file, not the other stuff. I don't really, because I have those files. I can. You just need to send me that one, really. So yeah, I mean, they're just files, right? Same difference. They're either files on your computer or files on someone else's computer on the internet somewhere. Uh, that's a lot. That might be as much as people want to take in for a day, because I'm worried that if we do another, it could take another whole hour. Um, let's look at what number 3 looks like before I make that determination. Yeah, number 3 is going to take similarly a long time, so um, what I'm going to do is split this into 2 parts. So I'm going to do another assignment of a similar length on Thursday. So um, if you're watching the video and you went through the boot camp today, we're going to do part 2 on Thursday, because it takes a while. And I don't want to burn people out at your computer. So we'll finish this part and send it to me, and then uh, Thursday we'll do part 2, and then unfortunately the timeline is sped up, but after Thursday you'll want to submit to me part 2. Now I will tell you that I'm probably going to do an additional one tomorrow during the Q&A, so um, that's another chance where you'll have to go, and I might skip, but I'm going to do Programming Challenge 3 from this boot camp stuff on Thursday, and I can do some other pieces. Ooh, that one's a big one. Anyway, probably tomorrow during the Q&A I'll do another part if you want to see it. So hopefully everyone understands what's going on. You're going to do 2 REPLs and 2 of these little mini projects um, for the final. Well, if you want the full points for the final. So here's part 1. This will be 150 of the 300 points. Submit it to me in one of the 3 ways that we talked about a couple minutes ago in the video. Tomorrow during Q&A, probably I will, if there's people around from this class, I will do a different exercise for part 2 to give you some options. And then on Thursday, I will do a part 2, sort of the official part 2. So today, tomorrow, and Thursday, you will have opportunities to get. You only need 2. I will do 3 this week. 1 today, 1 tomorrow, and 1 Thursday. So you need 2 for the final lab. But I think probably I should stop, because that's a fair amount of hammering away at the keyboard for a day. So does anyone have any questions that I can answer before we shut down for the day? I'll put a note. So video watchers, please look. Okay. Um, I can. Yeah, currently enrolled function. Oh, no, it will. It will. Actually, Nate, let me show you how to fix that. If it's showing a number, that's actually correct, but let's go fix it. So anyway, if you're on video, please look at the notes that are on the screen, and then I'm going to switch back to the code here in a second. Um, what we did today, Tuesday, May 27th, so we did part one of the C++ boot camp. The final is two parts. So we did one part today. We will do a second part tomorrow, Wednesday, May 27th. We will do a third part on Thursday, May 28th. You only need to submit two. So if you do the one today and the one tomorrow, then you're done. Or if you do one today and one Thursday, you're done. Or if you do one on Wednesday and one Thursday, you're done. If you want the full points for the lab. So it's 300 points total. You'll get 150 points for the two parts that you submit each, if that makes sense. Hopefully that does. If you have questions, please email me so we can make sure and get you straight. So that you don't lose out on these points if you're doing the work. Okay, so the numbers thing. Yeah, so mine is 2, and I'll show you how we would fix that. So I'll run mine and just to show you. Actually, there is mine. So mine also did a number. Now that's expected because in C++, when you print out a Boolean value and it's true, it by default it prints a 1. And when you print out a Boolean value and it's a false, it prints a 0. So the way to fix that is not actually, the way to fix that is in the output itself. So we're going to fix the output itself, and the way you do that is with this funky thing called, I think it's called bool alpha. We'll try it out and see if I get an error. Let me see if I get an error. Yeah. Okay, so this thing bool alpha that I've inserted in here, what that does is the Boolean that follows it will be printed Boolean in alphabetic. So this overrides the default, which is 0 or 1, and makes it print out in alphabetic form instead. Notice, by the way, there's extra operators around all that. So bool alpha is how we can turn that into alphabetic representation as opposed to numeric. So I'm going to try it. So notice that bool alpha made it come out as the alphabetic representation of true false. So it's correct that it comes out as numbers by default, and you can override that by saying that I want to print bools in their alphabetic form. Which is kind of cool. Weird, but kind of cool. Good that you noticed that, by the way, Nate. It's good to pay attention to those little details because sometimes there's meaning. In this case, in fact, there was meaning to why it was doing that. So that was good that you caught that and asked about it. Anybody else before we call it a day? So again, this was, I will present 3 different mini labs, and you only have to submit 2 for the final. Some of you have already done a mini lab. What was that other mini lab about? And it's on video, so if you're looking back, we actually did this Programming Challenge 1 mini lab with the bouncing balls in it. So that also counts if you did that. Then we've also done that mini lab. And then some of you also did the mini lab that was the vending machine. So this gives you a whole bunch of choices. The bouncing ball mini lab that we did, you can submit as one part. The vending machine mini lab we did, you can submit as one part. Today's mini lab, you can submit. Tomorrow's, Wednesdays, you can submit. Or Thursdays, you can submit. So in the end, there's five different, five? Yeah, there will be five options for submitting the two mini labs. Hopefully that gives everyone enough options to finish out strong. Okay, now I'm shutting up and I can field questions if you have them. I don't know what part to leave. And any questions that you have, I'm always happy to answer. So even if it's not one of these mini labs, which are really just labs, I don't want to call them mini labs, but they're more like mini projects. Anyway, any other questions you have? I'm happy to answer them. Otherwise, I'll shut down here in a minute or two. Okay, so everyone have a good night. Hopefully, I'll see some of you in the morning if you can make it for a 10 a.m. meeting, which is may not be doable for all of you, but I will post videos of that. So if you're there or if you're not, I'll post a video of us working through another one of these boot camp labs from tomorrow morning, and then I'll do another on Thursday afternoon. Just make sure that whatever you submit, it comes in by Friday this week. So I know it's puts a little bit of extra strain on you, but the semester ends on Friday, so um, that's what we need to make happen. Okay, so I will be back in the morning.